Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, reference angles. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any question about what we see today, or even your own homework, you can always put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 4 parts, so leave a like, smash subscribe, and let's get started. Let us first begin with the definition of a reference angle. So our definition for a reference angle is going to be as follows. Given any angle, any theta, between 0 and 2 pi if you're in radians, or 0 and 360 degrees if you're in degrees, your theta r, or your reference angle, is going to be the smallest positive difference between theta, this theta up here, and the x-axis. Let me say that one more time. Given any theta between 0 and 2 pi if you're in radians, or 0 and 360 degrees, your reference angle is going to be the smallest positive difference between that angle and the x-axis. Now you may be thinking, what does that mean? The smallest difference between theta and our x-axis. What is the value of the x-axis? Well, at this point in time, we should know that we have 3 possible values for our x-axis depending on where we are. And that's going to be true for both radians and degrees. So let's say we are on this line here. And of course, this is your y-axis and this is your x-axis. And you're starting here. Well, this is going to be our 0. If we're in degrees, our 0 degrees, right? 0 degrees. If you travel all over here, this is going to be our 180 degrees. And if you go all the way back, we're at our 360 degrees. So we have 3 possible values in degrees: 0, 180, and 360 degrees. But let's say we did the same thing for radians. Well, instead of having degrees here, what would they look like? So you're starting at 0 still, and you're going all the way to pi, and you're going to come all the way back, one full rotation, to 2 pi. So your 3 possible values for radians are going to be 0, pi, and 2 pi. So we're saying in this definition that if you have any positive theta between 0 and 2 pi, or 0 and 360 degrees, your reference angle is going to be the smallest positive difference between that theta and these numbers. Let's check it out and see what we mean. Let's say we're given this theta here, 235 degrees. And notice we're looking at degrees. So we're going to make sure that this given theta is between 0 and 360 degrees. And it is. Now we want to find our reference angle, our smallest positive difference. That means there's going to be some subtraction between this angle here, 235 degrees, and these possible x-axis values. So we're going to simply subtract them and see which one gives us the smallest one. So we have 3 possible values. 1, 2, 3. And it's going to be 235 degrees minus 0 degrees, right? And we're going to have 235 degrees minus 180. It's important that you set these up properly. It has to be positive. If it's not positive, then it's definitely not going to be a reference angle. It has to be positive. So you set up your equations that will give you a positive number. And your last one, 360 degrees minus 235 degrees. And we want to find out what are these values so we can find the smallest one of them. So right off the back, we know this first one is just going to be the angle itself, 235 degrees. We know this one is going to be 55 degrees after we subtract. And we know this one is going to be 125 degrees after we do the subtraction. So which one is going to be our smallest positive difference? 235 degrees, 55 degrees, or 125 degrees? Our 55 degrees. So we know that our reference angle for this angle here, 235 degrees, is going to be 55 degrees. Let's check out how this looks for radians. Now that we're in radians, let's say our theta is going to be 5 pi over 4. Now this is going to be between 0 and 2 pi. We've checked that, we're good there. We want to find our reference angle, our smallest positive difference between this 5 pi over 4 and these values here. So we have 3 possible values once again. And this is going to be 5 pi over 4 minus 0. We're going to have our 5 pi over 4 minus pi. And we're going to have 2 pi minus 5 pi over 4. Please remember, it's important that you set these up properly because you need to have the smallest positive difference. If you set it up in such a way you get a negative number, you're not going to find your reference angle. So when we do our subtraction here, we get 5 pi over 4 for the first one, we get a whopping pi over 4 for the second one, and we get 3 pi over 4 for the third one. Which of these is going to give us our smallest one? Because they're all positive. Which one's going to give our smallest difference? Once again, this one gives our smallest difference. Now this is not always going to be the case. It just so happens that the angles that we were given led us to our second value being the smallest difference. But that's not always going to be true. Do the math yourself and you can verify what's going to be your reference angle. One quick thing before we move on to our next part. I want you to realize that this is not just true for these two examples, but it's going to be true for all reference angles. Notice how small these angles actually are. This is 55 degrees. This is pi over 4. Both of these angles are going to be obviously positive, but smaller than 90 degrees, if you're looking at degrees, or smaller than pi over 2. This means that your reference angle, not just for these two, but in general, should always be an acute angle. If your reference angle is not acute, you are not doing something properly. So let's look at a quick visual to see how this plays out on your XY plane. So we talked about the definition, but what does the reference angle actually look like on an XY plane? So let's say we're given some arbitrary angles, one in quadrant 1, one in quadrant 2, one in quadrant 3, and one in quadrant 4. Now it doesn't matter what these angles actually equal because what's going to be true about this angle is going to be true about all the angles in quadrant 1. What's going to be true about this one is going to be true about all the angles in quadrant 2, and so forth. So these are just going to be representative. It doesn't actually matter what they equal. It's going to look the same way for your reference angle. So in order to create your reference angle, you're going to start with your terminal side of your angle. So this is angle 1. Our terminal side of our angle is going to be this line here, and we're going to complete this triangle. And the angle that we create right here between our terminal side and our x-axis is going to be our reference angle. So this is reference angle 1. We will do the same thing for each and every other reference angle. We'll start with our terminal side, and we're going to complete the triangle with the x-axis. We're just drawing a straight line down. We're always drawing straight lines, full vertical, full vertical. We shouldn't be doing any diagonals or any horizontals, full vertical. We complete this triangle, and this angle here is going to be our reference angle 2. The same thing over here. We complete this triangle. This angle here is our reference angle 3. Same thing over here. We complete this triangle. Notice everything is vertical. This angle here, reference angle 4. So it doesn't matter what angle you have in these quadrants, you're going to start with your terminal side of your angle, right? The angle given to you. Draw that line down so that it meets the x-axis, and then the angle you create that way is going to be your reference angle. However, notice that if you are in quadrant 1, your angle is going to be your reference angle. It's the same exact angle, but that's not true for any other quadrant. So this is how it visually looks on your XY plane to have reference angles. Given some random angles, your reference angles are going to be just like this. So we talked about the definition and we've seen it visually on our XY plane. Now I have some formulas for you. So all those people who are more formula based and you can remember a lot of formulas, you're going to like this next part. So stay tuned. So we're going to jump straight into 4 easy formulas to find your reference angle depending on which quadrant you're going to be in. For all of you who are really big on formulas, this next section is for you. Now, there's one real big thing that you need to know, and that's going to be where your boundaries for your quadrants. If you don't have that understood by now, you need to make sure you get that, because these are not going to make much sense if you don't necessarily know where your boundaries are for your quadrants. So that means that your quadrant 1, any theta in your quadrant 1 is going to be between 0 and 90 degrees. Now this is also going to be true for radians. I just wrote it here in degrees, but it's going to be true for radians as well. Any theta in quadrant 1 is going to be between 0 and 90 degrees. So it's going to be called theta 1 for our purposes. Any theta in quadrant 2 is going to be between 90 and 180 degrees. So our theta 2 is going to be between 90 and 180 degrees. Any theta in our quadrant 3 is going to be between 180 and 270 degrees. So that means our theta 3 between 180 to 270. Quadrant 4 has all the thetas between 270 and 360 degrees. So quadrant 4 is going to have our theta 4. So when we look at our breakdown for our quadrants, we can have some very nice formulas to figure out our reference angle. So if we're looking at our reference angle where our theta is going to be in quadrant 1, we know that this is just going to be our theta. If you're in quadrant 1, your reference angle is going to be the same as the angle. If you're in quadrant 2, this reference angle is going to be 180 degrees minus your theta 2. Now this is also going to be true once again for radians. So if it was for radians, you would do pi minus theta 2. For quadrant 3, that means your reference angle is going to use theta 3. And the formula for that is going to be theta 3 minus 180 degrees, or theta 3 minus pi. And if you're looking at an angle in quadrant 4, that means your reference angle is going to be 360 degrees minus theta 4, or 2 pi minus theta 4. So if you're really good with your quadrants and you can tell at a glance where your angle lies in quadrant 1, 2, 3, or 4, and you can remember these easy formulas, you can quickly find your reference angle by plugging in your necessary numbers. Just make sure that if you're in degrees, you're using degrees. If you're in radians, you're using radians. So let's use these formulas for two really quick examples to see how they work. So these are going to be our last two examples for today, and we want to find our reference angle. So our reference angle is unknown for both of these. So we want to first start with, where are our given angles? So for number 1, where is this angle? Is it going to be in quadrant 1, 2, 3, or 4? Depending on where it is, we will know which formula we need to use. 105 degrees is going to be in quadrant 2. That means our formula should be 180 degrees, because we're in degrees, minus our theta, which is going to be 105 degrees. So we can rewrite this as 180 degrees minus 105 degrees. Now that you can subtract this, you'll see that your reference angle is going to be 75 degrees. Now we can do the check. Is it positive? Yes. We know it's small. Is it an acute angle? Yes. This is indeed our reference angle for this theta 105 degrees. How about this one? You see, we're working in radians now, and we're at 5 pi over 3. Where does 5 pi over 3 fall in our quadrants? Quadrant 1, 2, 3, or 4? Well, 5 pi over 3 is going to be in quadrant 4. Quadrant 4, which means that our formula should be, because we're in radians, 2 pi minus our theta being 5 pi over 3. So now let's plug in our numbers and see what we get. So we have 2 pi minus 5 pi over 3. And we know we need to make this into fractions so we can actually do the subtraction. So 2 pi is just going to simply be 6 pi over 3 minus 5 pi over 3. And this is just going to give us pi over 3. And that should be our reference angle. Is this less than 90 degrees, or pi over 2? Yes, and we know it's positive, so it seems like it works out. This is going to be our reference angle when our angle is 5 pi over 3. So I hope you were able to follow along with today's examples, and I hope you now know how you can find your reference angles. But if you have any questions about what you saw today, or even your own homework, remember you can put it in the comment box below, or visit me on my Facebook page, @Tutor Me Sempai, and tell me all about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm looking forward to seeing you again next week, and I hope you had wonderful help with your homework today. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.